Okay, very good afternoon and salam sejahtera to ladies and gentlemen. Welcome to today online safety talk. Our title for today is how to choose a ductless fume hoods that protect you from chemical hazards. I would like to welcome everyone. We are from, I believe you all are from, some are from government institutions, private lab, industries. We also have our reseller joining us, and also a small portion of you are the furniture fabricator as well. So we have a large group of people. I think more are coming in. So we are very honored and happy to have you joining us. So allow me to quickly introduce Team Medical's Erlab and our speaker today. And we will have an hour and a half, an hour and 45 minutes together. So we'll start now, 2:45, and we'll try to end 4:30 today. All right. So let's start with why do we want to organize today's event? What prompted us to organize such a talk? Actually, I've been in the markets for a long time, and I've seen many ducted and ductless fume hoods. Sorry, the picture here is not ducted fume hood, it's a ductless fume hood, but it looks like a ducted fume hood. So we'll see a lot of local fabricated ductless fume hoods in the markets. So, but unfortunately, they are heavy. I would say they are heavy on HEPA filters, but they are weak on carbon filters. But I think this is very important for user to know this, because if you use liquid chemicals, so the things that protect you is the carbon filter, not the HEPA filters, because HEPA filters filter particulates. They are not be able to filter vapors and gases. So I think that prompts us to organize such a talk to not only provide information to the end user, but also to the reseller and also the lab equipment fabricators. I think we can work together with you, and I'm open to to talk one by one. Face to face with you to offer a better solution to the market. So first of all, allow me to introduce Team Medical and Scientific. We started in '97, but since 2019 we are part of the Nexus Analytics group, right? Nexus Analytics group is started in 2016. They are part of the bigger parents company called Melchers in 2017. So in technical terms, TMS is now part of the Melchers Group family, right? Melchers Group family is headquarters in Germany. So this is our website and our slogans: Team Gather, Better Solutions. So we want to be your team members, team players, for our customers, for our resellers. So we want to add value to you. So we have 4 groups of product range. Typically, the main one are the team safety equipment, the team food testing equipment, consumables. We have team meters, data loggers. We have team bio, basically life sciences equipments. So these are some of the products that we offer to our customers, and we try to our best to add value and provide the total solutions to our customers. All right, so that is basically the background of Team Medical Scientific. We look forward to work closely with you. Allow me to quickly introduce to you Erlab. I think most of you have heard about this, or some of you already using Erlab products in your laboratory. So Erlab is the inventor of the ductless fume hood since 1968. So they are the industrial leader with supply over 150,000 ductless fume hoods all over the world. They have 3 factories, basically in France, HQ, in China, and also in USA. So I think most of you know Erlab. Erlab is the name of the companies, and some of you heard about Captare. Captare is not the name of the companies, basically it's a brand name of the products. So if you heard Captare 321 Smart, that is the brand name of the products. All right, since 2021, Erlab has redesigned their logos to the light blue colors, butterfly logos on your right-hand side. So that is a new logos moving forward. Allow me to show you this short video clip to introduce you, Erlab's products and their filter technologies.
Erlab is, before anything else, an innovation company. We are specialists in filtration for the safety of laboratory personnel. Erlab was created in 1968 by my father, François Pierreville, and my mother, Marie Oville.
Back then, it was just a product that was designed to replace some of the safety holes into a lab. It was not meant to replace, as of yet, the traditional Fumehood, Ducted Fumehood, as we know it today.
Erlab today is, after nearly 50 years, still the leader in its market and the most innovative company in the industry when it comes to laboratory safety.
We have become experts at molecular filtration. So everything that we do, that we design, that we manufacture is based on that sole and unique technology.
For us, research and development is our business. It's our way of life. Erlab would not exist without research and development. Without research and development, Erlab would just be a product manufacturer. Erlab would simply put out a variety of products. Erlab is its own entity driven by its own passion, and research and development is what allows us to put together the very best of products in the industry.
To make sure that Erlab remains number one in the world in its profession, we have invested quite heavily in the most advanced state-of-the-art manufacturing means, robotics, new means of electronics, new generation electronics, new sensor technology. But for that to happen, you have to have at the heart of a company that aims high, the ability to research.
Customers are comfortable with our technology, and therefore we're going to continue to focus on this ever-changing evolution of the product line to remain number one in our business.
Okay, thank you. So allow me to introduce to you our speaker for today. It took me 6 months to invite Mr. Laloux for today talk. So I'm very honored and very pleased to have our speaker today, Mr. Dominique Laloux. Mr. Laloux is the Erlab International Sales Vice President. This is his current role, taking care all over the international sales under the Asia Pacific. So Mr. Laloux has vast experience in Fumehood industries, laboratory Fumehood industries. He started his career in 1983 in Erlab. So you can imagine next year will be Mr. Laloux's 40th anniversary in Erlab, and he has the honor to work side by side with the founder of Erlab. I'm actually delighted and excited to hear more of his wisdom and experience later on. So he is also involved, actively in the standardizations committee all over the world. So he is a member of the European Fumehood standardization committees, French Fumehood standardization committees, China, member of Tongji University, Shanghai, Chinese Fumehood standardization committee as well. So without further ado, I'll pass the time to Mr. Laloux. So he will bring us through from Ductless to Ducted to Ductless, and then how do we choose the right Ductless Fumehood to protect us while we are working in the lab, handling our chemicals. So I'll pass the time to Mr. Laloux. If I miss out anything, do, please introduce yourself further as well. Okay, thank you.
Wait a minute. Huh? Can you see now my screen?
It's still waiting. Okay, maybe you can reshare.
No. Cannot see.
No.
I share.
Yeah, you can reshare again?
I shared again.
Yeah.
So I stop sharing.
Okay, yeah.
Share again. Not working?
Are you in a full screen or you are?
No, I'm not full screen.
Yeah.
Now I am full screen.
Okay, I think you need to reshare again. Share the full screen slides.
Your screen sharing live. So I cancel, right? And share again.
True.
Now share full screen. Don't see anything.
Not yet.
I'm now talking to you from the new Erlab building in near Shanghai in China. It's very new here, so I don't know if there are some problem of communication.
Mr. Laloux, can you reshare again? I don't see your slide, but I can hear your sound clearly.
How about now? For me,
double click to enter the full screen mode.
It's a full screen now.
Maybe can you come up from the full screen and reshare again? Yeah, you come up from full screen and reshare again.
Share stop for the shares close. Okay. Something strange. Sorry, Joseph, I don't know what to do. Huh? I share, and for me on my screen is fully
yes,
shared.
you can see now. We can see now, Mr. Laloux.
Okay, okay.
Can you move to the next slide? So make sure I make sure the slide can move as well. Yeah, that's good. I can see now. Yeah, okay. You can start.
Sorry for the technical problem. Okay, thank you very much for attending my lecture. I am Dominique Laloux. I am in Erlab since 1983, and I have accumulated for the last nearly 40 years quite a lot of experience, particularly for Ductless food, but also for Ducted one. And I am trying today to deliver to you information that I think can be valuable for you. Got it? Okay, valuable for you. I'm going first to talk about a comparison between ducted and ductless fume hood. First, what is a ductless, how it works, to remind you how it works. First, you have on top of an enclosure blowers, which are going to suck air from the room, penetrating the enclosure through a sash opening. Then that air is going to take the chemical vapors or chemical particles to filters, which are going to retain those chemicals. And after the chemicals are retained in the filter, the clean air is returned into the lab room. If I compare that with ducted fume hoods, totally different. Ducted fume hood works with auxiliary air. If you don't provide air to the ducted hood, you don't have air exhausted to outside. So the first thing is you need fresh air from outside to be introduced. You need air conditioner and filters to filter that air and put it at the temperature of the lab. Then that air can be shared between the room itself, what we call the air change rate, to change the air of the room, and part of it will be used by the fume hood. For example, in this case, I put a fume hood that delivers 1,800 cubic meters per hour. Okay, so the total air that will be exhausted will be 1,008 plus 1,200 for the air change rate, will be 2,900. You will say, I'm not good at math, but in fact, you have to exhaust a little bit less than what you introduce to create a negative pressure in a lab. Now, what are the benefit and the constraint of both systems? If we look at the ducted one, the biggest benefit of a ducted one is that it can normally be used for any kind of chemical in any quantities. But it goes with several issues. First, such a fume hood consumes a large amount of conditioned air energy. It is estimated that one ducted fume hood that works 8 hours per day, 220 days per year, will consume as much energy as a big house with air, which is aircon full time during a year. Now, it's difficult to give you a cost in US dollar or Malaysian ringgit or whatever, but remember that is the cost of a house, a big house, which is aircon full years for one ducted fume hood. It's a huge energy consumption. It's complicated and expensive to install, as you can see. It goes with tubing, ventilators, air conditioning system, filtration system, not easy at all, and very critical to make it well if you want the fume hood to work well. It pollutes the building environment. The chemical goes outside. There are some systems to retain chemical, but they're also complicated. And beside acid with scrubbers, no other system can filter properly chemicals. And its fixed, cannot be moved. So when you install it, you cannot change the location. What you can do is possibly add a new one, but it's not easy because you have to change completely the auxiliary air system, introduce more air, increase the size of the air conditioning system, the filtration system. So it's not easy at all. So you cannot actually increase easily the number of fume hood with ducted in a chemistry lab. Now looking at the ductless one, a ductless one can be used with, can be used with well-filtered chemical and limited evaporation. It cannot be used with, of course, with chemicals which are not well filtered, and it is limited in terms of chemical evaporation, because if evaporation is too large, the filter life will be too short. It doesn't consume any conditioned air energy because the air of the room returns into the room, is not consumed at all. So it's a saving, a very large saving of energy. It is easy, fast, and economical to install. You just need an electrical socket. You install your fume hood where you want in the lab, you plug in, and you can already work with it. No pollution of the building environment because the chemicals are retained in the filter, don't escape to outside. And wait a minute, because my screen bothers me a little bit. The number of ductless fume hood that you can install in the lab room is not limited. Since you don't consume air, you don't have any auxiliary air system working for the ductless hood, you can put as many as you like. It means you can actually increase safety as much as you can with a ductless fume hood. So basically, the two products, ducted and ductless, should go together into a lab. The ductless one shall be used for handling small to medium quantities of chemical emitted, when the ducted one shall be used for large quantities of chemical and a wide variety of chemical. It's actually can go in various proportions. It depends on the type of lab. According to our experience, pharma lab, for example, can accept 80% of ductless fume hood. Petroleum lab, because they use large quantities of chemical, only 40% of ductless can penetrate into petroleum lab. Food processing, 80%. University, easily 90% of ductless can equip university. So ductless potentially can represent 40% to 90% of the total of fume hood installed in chemistry lab. The energy saving of the lab are more and more encouraged with green financing to obtain a LEED certified building or even zero net energy certified lab building, which is going more and more popular in America. We have plenty of cases, but here I selected three. For example, the Framingham University is using 49 ductless fume hood and only 4 ducted fume hoods. They have ducted fume hoods, only 4. And they have been certified LEED silver label. Bridgestone, in their R&D center in Akron in USA, they are using 11 ductless fume hood and only 1 ducted fume hood. And they are certified LEED gold. And another case which is quite interesting is Bristol University in USA, which is using 13 ductless fume hood and 4 ducted fume hood. And that lab has been certified zero net energy building. It means that building produce as much energy as they consume. And they could only obtain that result by using the 13 ductless fume hood. So why should we nowadays privilege a ductless fume hood? For that reason, that it is encouraged by government to go for green environment, but it's also because in the lab, more and more chemical handling are automated, reducing significantly the evaporation of chemical and are appropriate for ductless protective enclosure. Ducted protective enclosure is similar to a ductless fume hood, but it's not for handling. It is for covering instrument, for covering automate, which are installed somewhere in the lab. And they have the flexibility to be installed anywhere. Flexibility is a key word today, the critical key request for modern laboratories. Laboratories need flexibility because the technology changed so fast that they need flexibility. And ductless filtration fume hood participate to that flexibility. Only ductless fume hood or ductless enclosure can fulfill all those requests. What are the basic principles for the choice and use of a ductless fume hood, which is the topic of today? First, a ductless fume hood shall fully comply with the relevant safety standard. Second, it shall be appropriate to the type of chemical handling supposed to be performed. Third, it shall be used with discipline. Let's talk about the standard first. There are several standards just dedicated or mentioning a specification for ductless fume hood. Particularly in USA, Canada, where you have, for example, the CEFA9 standard, which is fully dedicated for ductless hood. You have the NC Z9.5, which actually is a standard for general ventilation in labs, which has a big part dedicated for ductless hood. The NFPA 45 standard, which is a national fire safety standard, which is now going to dedicate a big part to the ductless, to the safety of ductless. We participate to the NFPA, and that will be released in 2023. And the CSA, the Canadian standard Z3116.5, which is a standard for Fumehood, and which has a part dedicated for ductless hood. In Europe, we have the French NFX 15-11, dedicated to ductless hood, the UK BS 7980, also for ductless hood, the Germany DIN 12927, and we have a EU standard which is under development, and Erlab is a member of the European Committee to develop that standard. In Asia, we have two main standards. One is a Chinese one, the JGT 385, which was developed and released in 2012, an Australian standard, AS, and also New Zealand, 2243.9 from 2009. Which one should you follow? Actually, I list here the most important criteria for the safety of a ductless hood. There are many others, but here I cannot talk about all of them. The most important one is to get from supplier a list of retained chemical showing the filtration capacity of the chemical at a certain percentage of the permissible exposure limit. I will come back to the permissible exposure limit. The phase velocity of the enclosure is also a criteria, which is not only for ductless, but also for ducted. The containment efficiency will actually talk about the capacity of the enclosure to contain the chemical. Also a very important criteria for ducted and for ductless. Then for ductless, the filtration efficiency and capacity, specifically for ductless, which will be a percentage of the PEL. PEL is permissible exposure limit. Let me show you what the name PEL. PEL is permissible exposure limit, is actually developed by the OSHA, the Organization for Safety at Work in America. And you have also in Malaysia the PEL, permissible exposure limit. It has other name. For example, in France, it's called the VLEP, professional exposure limit value. In Germany, it's called MEK, maximum acceptable concentration, professional exposure limit. In Australia, New Zealand is OEL, occupational exposure limit. And in China is a PC-TWA. TWM is time weight average, which is a permissible concentration for chemical in China. But all of them actually mean the same. They are not exactly all same, but they mean the same. It's actually your protection towards the chemical when you inhale it up to 8 hours per day, the concentration. Okay, that's the meaning of the PL. So in this lecture, I'm generally speaking about PL, permissible exposure limit. Which one to select? We advise you to go for the French one. It's the one which is the most popular in the world now, and the one which is the most stringent among all the other standards. As you can see, the BS not so good in terms of phase velocity, in terms of filtration efficiency, 100% of the OEL or PL is too much. The DIN is a very old standard which has not been updated, so don't specify the main criteria. The JGT is good, but limit the retained chemical to 20 chemical only, when normally there should be no limit. And the EZ standard don't require any chemical listing, don't require any containment capacity, don't require any specification for the filtration efficiency and capacity. Okay, so we advise you to go for the NFX 15-11. The list of retained chemical, which is the first point. The list of retained chemical obliges the manufacturer to publish a list of chemicals that he tested in his own testing laboratory, showing the quantity of chemical in grams that he obtained in its filter at a filtration efficiency of 1% of the PEL, the permissible exposure limit, okay, of each chemical. This list is not limited. A manufacturer can publish as many chemicals as he wants or as he can. The PEL, permissible exposure limit, or OEL, is again the concentration of a specific chemical that you are allowed to inhale 8 hours per day. The list of retained chemical is designed actually to help the customer who want to buy a ductless hood to compare the retention capacity of a specific chemical at a filtration efficiency of 1% of the PL between several manufacturers. Let's take, for example, acetone. Manufacturer A can retain 800 grams, manufacturer B can retain 1,200 grams, manufacturer C can retain 400 grams, okay, B is better, okay? So you can compare using the information in the list of retained chemical published by the manufacturer. The quality of the list reflects the level of professionalism of the manufacturer. The more chemicals are published, the more chemicals have been tested by the manufacturer, and the more the manufacturer is professional. And the manufacturer is responsible for the quantity retained indicated in the list, and anyone can ask a third-party laboratory to verify that those quantities are correct. What you find in a chemical listing, you find the chemical names, for example, here on the left. You will find the PL, the permissible exposure limit of the chemical, PL TWA. TWA means time weight average over a period of 8 hours. You will find the type of filter which is suitable to filter this chemical. And you will find the quantity of chemical retained in the filter at 1% of the permissible exposure limit. For example, here, the first chemical is retained 1,395 grams, etc. Okay, that's a typical official chemical listing according to the NFX 15-11. So there are 3 main requests for the safety of a ductless hood. As mentioned before, the air phase velocity is one of them. It consists in an air barrier at the sash level between the chemist and his chemical handling, to create a barrier between the chemical and the chemist. The containment capacity is extremely important. It consists in verifying if possible turbulence inside the enclosure don't provoke a release of chemical to the chemist through the front sash. And the last one for ductless hood is a filtration efficiency and capacity test. The criteria to determine the filtration efficiency and capacity of the filter to retain chemical at a requested filtration efficiency. Let's go for the first one, the phase velocity at the sash opening. The velocity of the air entering the enclosure through the sash opening shall be maintained between 0.4 and 0.6 meters per second at the sash. Besides being a barrier, the phase velocity is also used to counter the draft generated by movement in front of the fume hood sash, which tend to suck air from the enclosure through what we call a Venturi effect, such as, for example, sailing air conditioner, people passing by the hood, doors being open or closed. I give you here an example of Venturi effect with people passing by. When they pass by, they tend to take air from the fume hood. So actually, the phase velocity is designed to counter this effect, avoid people passing by to take air from the fume hood through the front sash. Again, there are others like the doors, like air conditioning systems, the draft of air conditioning system, who can provoke this kind of problem. Here is an example how the phase velocity is measured. You have here the opening, two openings actually, and you make you put some wires to actually determine points where you are going to measure the phase velocity. Here you have 8 points on the grid to measure the phase velocity. You are going to use for that a hot wire anemometer, and you are going to register at the 8 point what is the phase velocity, and then calculate what is the mean velocity, means the average velocity obtained, which should be between 0.4 and 0.6 meters per second. One thing to the phase velocity, 0.4 is a minimum. 0.4 is a minimum to counter draft in the room. Okay, 0.6 is the maximum. The phase velocity should not exceed 0.6. Many people think the higher the phase velocity, the better. It's totally wrong, because the higher phase velocity in the ducted hood or in the ductless hood, the more you create turbulences inside, and those turbulences may create a release of chemicals through the front sash to the user. So that's the purpose of the containment issue that I'm talking about. Containment is actually a test which is going to verify by emitting a gas inside the enclosure. Generally is SF6, sulfuric hexafluoride, which is a tracer gas, which is emitted inside. And according to the American standard, the ASHRAE 110, which determines the method to verify the containment, you should not find more than 0.05 ppm of SF6 at the nose level of a dummy placed in front of the hood. Okay, so there is another standard which specifies the value that you should not obtain. It's the NC Z9.5. So the two standards go together, and ASHRAE for the method, NC for the value to obtain. And you have another standard, which is the EN 14175, the standard for ducted fume hood, which specify that, which measure the escape of SF6, not through a dummy in front, but exactly at the sash level. And according to the XPX 15206, specifies that not more than 0.1 ppm of SF6 should be detected as the sash plane of the fume hood. Then you have the filtration efficiency and capacity. The air recirculated in the lab room, according to the NFX 15-11, should not contain more than 1% of the permissible exposure limit of the chemical used in the fume hood. Remember, the PL of a chemical is the concentration of a specific chemical that you can inhale safely 8 hours per day. So 1% of the PL, why 1% of the PL? Means actually 100 times below the allowed concentration of the chemical, which can be released into the room. That's the maximum. And because you can actually get 1%, 1% allow you to handle safely a mix of chemical in a ductless hood. Because if not more than 1% of each chemical can be released into the room, the addition of this 1% won't never reach a high level of concentration, which can be dangerous. Nobody knows what will be the PL of a mix of chemicals. So 1% gives you a very high safety margin. The standard requires 3 chemicals to be tested at least to comply with the standard. One is isopropanol, another is cyclohexane, and last one is hydrochloric acid, to determine the quantity of each chemical retained in the filter at 1% of the PL of those chemicals. The test consists in evaporating the chemical, which is introduced progressively inside the enclosure, to check permanently the concentration of chemical downstream the filter. And when the concentration downstream the filter reach 1% of the PL of the chemical, you stop the process and record the quantity of chemical retained in the filter. You need for that balance, hot plate, peristaltic pump, and PID. PID is a detector, gas detector. For example, here, after they get your report, here cyclohexane had been tested. The concentration evaporated was 180 to 230 ppm. The test lasted for 9.3 hours. The highest concentration measured in the enclosure was 226.7 ppm. The PL of the chemical is 200 ppm. So 1% of 200 ppm is 2 ppm. And when we reach 2 ppm at the exhaust of after the filter, we notice a quantity of 1,155.8 gram retained. Now, another request of the standard is very critical, very important, is a request of providing a chemical assessment. Prior to selling a ductless hood, it is required that the manufacturer or the distributor shall submit to the client a questionnaire to evaluate if the intended chemical handling can be performed safely and economically in the ductless hood. The manufacturer shall verify if all chemicals used in the handling are well filtered. He must determine what is the appropriate filter to use, evaluate how long the filter can last, determine also the appropriate breakthrough detection system. Two possibilities. One, the manufacturer estimates that the handling is not applicable in the ductless hood. Some chemicals are not retained or not well retained. It should specify which one are not retained. Maybe those chemicals which are part of the handling can be used in the ducted one, and the other retained can be used in the ductless one. The estimated filter life expectancy seems to be too short. For example, less than 6 months. We in Erlab, we recommend a lifetime which shall be above 6 months. Less than 6 months, we don't recommend a ductless hood. And there should be some comment giving advice how to make the handling applicable, such as solution to reduce chemical evaporation. It may be possible to reduce chemical evaporation, which is actually the main reason why a ductless hood cannot be used. If the operator, the chemist, can reduce it, he can make the application suitable for a ductless hood. The second case is handling is applicable in the ductless hood. In this case, the manufacturer shall confirm that all chemicals are retained in a specified filter, determine the filter, determine the filter life, which is estimated to be over 6 months, determine the breakthrough detection system, and preferably automatic detection system to know when the filter is saturated and must be changed. So the manufacturer, in this case, takes the full responsibility of his response. If ever he sells the unit and for the application which has been authorized by the manufacturer and it doesn't work, he is responsible for that. So the conclusion to select a ductless hood that guarantee your full safety, the first thing is to make sure that the manufacturer is professional. And to verify it is to get the list of retained chemicals that I mentioned first. When you check the list of retained chemicals, verify one thing. verifies that the retention capacities of the chemical in the filter is indicated. You can find sometimes chemical listing the chemical, listing the PL, listing the type of filter to use, but not the retention capacity. But this is the most important information that you should find in the chemical listing. You can compare, when you have several chemical listings, which supplier offers the highest retention capacity for the chemical you are supposed to be used, and then select to go for the one who has the highest retention capacity. You have to ask the manufacturer to which safety standard he pretends to comply. Then privilege manufacturer complying with the NFX 15-11 and verify their official test report, air phase velocity, containment efficiency report, filtration efficiency report. Make sure that the manufacturer or its distributor will provide you a chemical assessment document to verify the applicability of your intended handling and deliver clear answer, either negative or positive. Never buy a ductless hood without a validated chemical assessment in written, engaging the responsibility of the manufacturer. Last but not least, make sure the manufacturer or his distributor can provide you with a very professional online and on-site after-sales service. Those are the 7 points which are critical to select a ductless filtration fume hood. Now I want to explain to you how we, Erlab, we guarantee your safety with a ductless hood. The first thing that Joseph already mentioned, Erlab has 54 years of expertise in ductless filtration fume hood. We have a French company established in 1968, the American one established in 1981, and the Chinese one established in 2004. We have a strong worldwide sales organization. Over now 200,000, it's no more 150, but over 200,000 ductless hoods sold and used, and a network of over 90 regional distributors, whether in American continent, in Europe, in Africa, and in Asia. What is very important in Erlab is R&D lab. We have R&D lab since if I remember well, 1970. We started in 1970 to study the filtration of chemical with our own laboratory. We have 50 years of research and development fully dedicated to the filtration of chemical in ductless hood. Believe me, it's a lot of research. We tested thousands of chemical and mix of chemical in our laboratory. Our laboratory has increased and developed a lot. Today, it occupies about 1,000 square meters in our R&D center in France. The list of retained chemical published by Erlab contains 600 chemicals listed with retention capacity at 1% of the PL of the chemical, according to the NFX 15-11. Thousands others have been tested over the 50 years, but not published because it's too many. We fully comply with the NFX 15-11 standard. We have a certificate from Intertech, from SGS, from Tongji University, from Golder, and even our own internal certificate. We offer, and I'm not going to describe too much a product today, we offer what is very important, a flex filtration column, which is actually an invention of Erlab. It contains this column, several filters, and a blower box, which is located between filters to suck chemicals through the filters from the enclosure. One very important development is to provide what we call the Neutrodyne unisolve filter, which is a filter capable to filter one single filter capable to filter many family of chemical, solvents, acid, ammonia, formaldehyde. It's a unique development of Erlab, unique in the world, which avoid to use different filters according to the handling, using, for example, a filter for solvent, or a filter for acid, or a filter for ammonia, or a filter for formaldehyde. This one can take all of them. This filter is presently used only for what we call the green Fumehood range of Erlab. It's still not used for the Captain range, but will be within 1 or 2 years in the Captain range available. Together with the molecular filter, which retain vapors, we offer also the best of particulate filtration with very high level EPA H14 or ULPA U17. Both filters can be combined in the filtration column. The molecular filter is used to retain vapors, and the particulate filter is used to retain particles. So when you have both vapors, liquid chemical that you evaporate, and you have powders, then you use both in the filtration column. Another system of Erlab is called the revolving layers of filter. On top of the enclosure, you have operational filter. Above it, you have the blower, and above that one, you have the safety filter. The situation is such that when the operational filter is saturated, you get an alarm in the detection chamber, in the blower chamber. Okay, then it means chemical passing by the operational filter, then it means the operational filter shall be changed. But you have a safety filter which prevents any chemical to go into the room. Then when it happens, what you have to do is to remove the operational filter and dispose it. Then you are going to take the safety filter to replace the operational filter. The safety filter and the operational filter are exactly the same. And then you put only one new filter, a new safety filter, to be installed. This system is designed to guarantee that no chemical will be returned into the lab until the saturated operating filter is changed. So this guarantees that even if the main filter, the operational filter, is saturated, no chemical will penetrate the room. Now, talking about the assessment of your handling. We have a very specific system in Erlab that we developed for now 4 years, which is called the Eval Request. It's not an Excel document, the one I showed you before. It's an online way, an online system where you get access on internet through the http evalrequesterlab.com, where you are going to get to deliver the information needed to evaluate your handling and verify if it is applicable for Erlab Ductless Fume, and get it immediately. So online at your fingertip, you are going to go to the Eval Request website, and you are going to fill in the information needed. I'm not giving, because of lack of time, to detail all the things, but it's very user-friendly. You just follow the system. You, for example, say, what kind of handling is that? Okay. After that, you mention which chemical are used, how they are used, whether they are used heated, not heated, in a large container or small container, the frequency of use, etc. You have a rolling menu to deliver this information. So the online system should validate or not your chemical handling, determine the appropriate filter, estimate the filter life, suggest the filter saturation detection device, the breakthrough system, determine the suitable Erlab Ductless Fumehood, and help you to select accessories like detection device, like table, worktop, and those kind of things. You get it, you get the answer almost immediately. I show you how it works. You submit the Eval request online, and information go to the Erlab servers in Europe, integrating 50 years of R&D and feedback of several 100,000 chemical handling from customers that we capitalized for 50 years. Then If the answer is positive, the chemical handling is validated, you can go for the Erlab Ductless Fume. Okay, and then you know all the information that I mentioned before, which filter, which detection system, what will be the estimated filter life. You get all the information. If not, then you don't get the answer immediately. A message will tell you, we are going to re-verify your application. Then it goes to the R&D team in France, which within 48 hours will verify the application, which normally is maybe not suitable, but they verify it. If they consider that it is suitable, they will deliver validation, and you can go for the ductless. If not, you have to go for this application for the ducted fume. So with that system, if you use it systematically from your lab, from your computer, you know for any application you intend to use, you know whether a ductless fume is suitable or if you go for a ducted one. And I encourage you to use it systematically. Like this, you will see many applications actually are suitable. Generally, we estimate that 70% of the chemical application are suitable for ductless and 30% suitable for ducted one. So you get the fully report, the Eval Request, that's what you get. And that report is also transferred to your distributor, who will contact the user, contact for quotation, for delivery, for installation, and for commissioning. So what happens if the chemist change its chemical handling? You buy the unit for a specific chemical handling, but later, maybe a few months later, you want to change it. You change the type of chemical, the quantity of chemical, the type of beaker, whatever. What you can do is to use again the Eval Request. You just go to the Eval Request again. You enter the information about the ductless fluid you are using already, and the filter, and inform about the change in the handling. And you get right away an update. If the filter you have is still appropriate, if the filter life is modified, and if the saturation detection system is still appropriate. So that's part of the discipline that I mentioned before at the beginning. Discipline is extremely important using a ductless fluid. It's not the ducted one. So you have to verify that the chemical you are using are appropriate and well filtered. You have to verify that the quantity you are going to evaporate are suitable to allow the filter to have a long filter life. So this Eval Request allow you at any time to verify it, which is extremely important. Before we had a manual system, we had an Excel system. It was relatively long. It takes 48 hours to get the answer. Now you get it directly online. So you can actually, we encourage you to be very disciplined for the use of your chemical handling. Eval Request is actually, should be your companion of your safety. It should accompany you anytime you use your ductless fluid, or you have a new application, you want to buy a new Fumehood, and you want to verify if it is suitable. We have another system called eGuard, which is an app which is designed to control remotely all the Erlab filtration devices in the lab room. Actually, Erlab not only make ductless Fumehood, but make also ductless storage cabinet, make instrument enclosure, room air purifier, weighing station. You make a variety of products using filtration. And from your computer, before we were using also the mobile, but we are holding this one for a while because some were using iPhones, some were using Android, and iPhone and Android, they keep changing their soft, and it's quite complicated for us to adapt to it. So very soon, you are going to be capable again to use your mobile, but you will have to go to a website very soon. So from your computer today, you can control for each unit the airflow, the phase velocity and the filter saturation at any time and where you are. You can have the unit in China, you can be in America, you can control anytime, 24 hours, the condition of the Erlab enclosure using filters. Talking again about TMS. TMS is our distributor since 2020. TMS is a company that we cooperate for a long time, which cover very well the territory of Malaysia, the Western Malaysia and Eastern Malaysia, by themselves and only through local sub-distributors. And they support them extremely well. That's why we are very satisfied working with TMS. The policy of Erlab is to cooperate long-term with our regional distributor. TMS, in an example, in 2020, not 2020, sorry, 2002, sorry, I made a mistake, 2002, sorry for that. So a very long time. We cooperate with Japanese distributor for now more than 12 years, with Korean distributor since 1989, with Australian distributor since 1985. So the cooperation with distributor is very important because you need to accumulate a lot of experience to deal with ductless food, and TMS is a perfect example. They have an enthusiastic and well-trained team for the sales and after-sales of Erlab product. Very nice central office and warehouse in Kuala Lumpur when all the unit and replacement filter are available. We have 22 years, sorry, I made a mistake with 2020, it's 22 years, 2000 in fact. We started 2000, 22 years of very friendly and professional cooperation with TMS. Thank you for attending this lecture. Today, I would like to tell you many more things, but time is limited. So the concern of safety with Fumehood or Ducted or Ductless is a very serious one, not an easy one. So I advise TMS to give you a questionnaire where you can mention what additional topic you would like to be treated. And if I can be of help, I will be very happy. Thank you. Thank you very much.
Thank you, Mr. Laloux. Thanks for, within 1 hour, you condense everything with a lot of information for us to digest. You mentioned about, the air velocity, you mentioned about the containment test, you mentioned about the retention capacity, flex technology, the Erlab safety programs, Eval Request. So there's a lot of things here. So maybe before I open up the sections, Q&A sections to the audience, allow me to ask you a few questions first while we are receiving questions from the participants, right? Before that, maybe I have paused the feedback form in the chat box, in the chat room. Feel free to fill up the feedback forms. Inside this feedback form, we ask you about a few questions, including what is the topic of interest for the next public talk. So we will actually arrange for that. We also ask you about whether you want to have a certificate of participants. Do let us know. We only give up the certificate upon request. So if you want the certificate of participant, do fill up the form. We will actually pass it to you. All right. So do fill out the form. I try to show the try to get the QR code for you as well. So but anyway, I will share. You can use the link to go into the feedback form. All right. So keep the question coming. So I will ask a few questions first, and while waiting for your questions. All right. So Mr. Laloux, thanks for the presentations. I have a question for you. All right. You mentioned about, whenever I meet up with customers, they will say, I want a Fumehood with a very solid structure, a very huge, a very, thick wall and all those things, but they forgot about the the ductless fume hood, the most important tip parts is the filter, is the carbon filters itself, right? So that's why you put a lot of information, emphasize on the filter efficiency, the filter capacity, and all those things. So my question, so what is the uniqueness, if you want to summarize it, what is the uniqueness of Erlab filtration technology compared with the others, carbon filter supplier? Example, American air filters, Japanese air filters, Japan air filters, they also offer carbon filters, right? So what is the uniqueness of Erlab carbon filters compared with the others manufacturer?
Well, Joseph, actually my answer is very simple. Our filters are tested with a huge variety of chemicals. When the filter offered by the company you mentioned are not tested at a filtration efficiency of 1% of the PL, okay? That's the result which is important, not the way you make the filter. And the way is, you are free to make it the way you want. What is important is the result. Our filters are tested to a huge variety of chemical, at least the one which are published in the chemical listing, and at a filtration efficiency of 1%. And I explain why 1%, not the PL or more than the PL. It's 1%. Okay. It's unique, absolutely unique. So that's my answer, Joseph.
All right, thank you. So I have a second question to you, is to tap on your experience and your your expertise. So what do you see the trend going forward for fume hoods in the laboratory, especially the green fume hoods, the sustainable, environmental friendly green fume hoods moving forwards? So what is the trend? Can you share with us in terms of globally the trend that we can see?
Yes, the trend is changing. I am in Erlab nearly 40 years. When we started with Erlab in 1983, we were very marginal, very marginal. But at this time, when I entered in 1983, we already have R&D lab. We were very small. Honestly, we were very small. But the vision of our president was already to consider that in some period of time, our technology will surpass the ducted technology. And he is starting to be right. It has taken time. It's very normal. Many customers, when you talk about ductless hood, where you are going to recirculate the air into the room, honestly, their first reaction is to be a little bit scared. They say, but if the filter not so good, then the chemicals that I enter in the enclosure are going to come back to me. So I better go for ducted. That's a very natural and human reaction. Okay, that's why Erlab keeps studying the filtration and deliver filters that are extremely efficient in terms of filtration efficiency. 1% of the PL is not easy. And also offer a larger and larger capacity of chemical retained in the filter. So the filter life is getting longer and longer. When I entered in 1983, the capacity in the filter was far from what we reach today after so many years of R&D. Okay, so we can see now the trend in America and in Europe and in Asia, and particularly in very developed countries. We can see the trend going more and more for ductless hood because the credibility of the product is there. And what is very important is to be extremely clear with the customer, not to try to sell the product at any cost. Erlab is not like that. Erlab, we verify. The handling is possible. We agree to sell our product. The handling is not possible. We disagree to sell the product. It's a rule in Erlab and rule that we apply with all our distributors. That's the first thing we teach our distributor, okay? And that's also the reason why the chemical listing is so important. But the trend, again, is going up and up because the request for environmental protection and the saving of energy is getting higher and higher and higher. More and more subsidies are delivered to laboratories to be greener and greener and greener. And the other reason that I mentioned also before is flexibility. A ducted hood is not flexible. When you install it, it's finished. You cannot move it, but the lab needs flexibility. When you have instrumentation, when you have a robot, which are chained together and installed on the worktop, you need to cover them when they use chemical, but you cannot put a fume hood there, impossible. But a ductless one, yes, you can, okay? So all those requests today, the energy saving, the pollution of the environment, and the flexibility plead in favor of ductless filtration enclosure and fume hood.
Okay, thank you very much. So we have some questions coming in. We have two here. Maybe I'll start with Katie questions first, and then I will go for Ethan Go questions. So Katie is she is a reseller, so she has this question. So she encountered limitations while offering ductless fume hoods for the local end user, especially when they are dealing with acid digestions and also applications that uses high temperature. So her question is, does Erlab have any new models that can, that can cover these applications? So she's mentioning about the digestion, she's mentioning about the high temperature.
Basically, no, Joseph. For this kind of application, the quantity evaporated are much too high and the filter life is going to be too short. But there are new systems today, I don't have them in mind now, but there are new systems today which allow to actually reduce considerably the quantity evaporated. And those systems, when they are used, can be enclosed in a ductless. Okay. But if you perform it, I would say on the open bench inside the enclosure, but on the open enclosure, then no, definitely not. This kind of typically handling is to be performed in what we call acid fume hood, which is also a very complicated fume hood, which must resist to the chemical, which must be equipped with scrubbers, with a water curtain at the back of the unit. So it's quite complicated, even for ducted, not easy.
I agree. Example like acid digestion with heating mantle. So typically you do need a wet scrubber to come together with the ducted fume hoods. So, yeah. So what we are mentioning here is if you are doing acid digestions with heating mantle, if you are using, furnace with a high temperature, maybe ductless fume hood is not suitable for you. You should go for a dedicated ducted fume hoods, right? So, but like what Mr. Laloux says, 70 to 90% of the applications, ductless fume hood is suitable for you. But no harm for you to fill up the Eval Request form. We will always welcome, to share whether, to test whether your application is suitable for, for a ductless fume hood or not. So the Eval Request questionnaires are free, so you can do it anytime, anywhere with an Eval Request. So for information, previously we are using Excel sheets. Now we are slowly moving into the Eval Request. So do check out with my colleagues. We will actually share the link so you can use Eval Request to fill up the Eval Request. At the moment, we have Eval Request for the fume hoods. The coming months, we will have Eval Request for the storage as well. Okay, so come back to another questions from Ethan. Ethan is particularly interested on the safety filters. Mr. Laloux, you show us the two layers, right? The first one is the operating filters. The second one is the safety filters. So Ethan is asking, may I know the ductless fume hoods with safety filters, is it first in the market? It is the first introduced in the market?
Yes, actually, we introduced this technology sometime around 1995 with a patent. It was a patent of Erlab, The product name was Toxicap at this time. But you know, a patent lasts 20 years. So the patent is over. So anyone can use it. And it is even more and more recommended as a standard. I can see, I show you before the American standard, the NC Z9.5 recommend the double filtration system and recommend also the filter to be same. This is very important if you want to proceed to the exchange of filter. Okay. The NFPA will recommend also, and what else? I think the two are recommended now. Yeah, we are happy. It's a development of Erlab, but we are happy to see it. What we want is to whatever customer buy, that he gets the best protection, and two filter is critical.
Okay. Okay, we have new questions coming in from Diana. She said these customers, Sing Lab require, okay, so this customer require a new fume hoods. So he wants something, is a combination of having a ductless fume hood, but the ductless fume hood has a ducting exhaust system. So they require to connect the duct.
I don't know why, because you lose a big benefit of the fume hood. You lose the flexibility, you lose energy saving, so you lose a lot. But okay, it has sometimes happened that customer want to duct out. In this case, you just put a canopy above the filter, a canopy, not you don't connect directly to tubing. You put a canopy that will cover more than the surface of the filter, okay? Then part of the air will come from the room, and part of the air, the other part of the air will come from the fume hood. And the blower on the roof should take more air than what is delivered by the ductless hood, okay? The rest is going through on the side of the canopy to avoid any return of a chemical into the room. Honestly, I don't recommend this system. There is no need at all. And again, you lose most of the benefit of the ductless.
Which means they can do it. I mean, a combination of both.
You can do whatever. Yes, you can do.
Yeah, I think I understand.
I know that it was, but very few customers do that.
Yeah, I think there is a obvious benefit that over there is because they don't want to have a chimney outside the buildings. They want to have just a ducting, to duct up the excessive vapors, just in case it came up from the ductless fume hoods without, changing the filter on time.
I would recommend to use all the benefit of the ductless, to use it for what it is capable to do, and take benefit of all the advantage of the ductless. For example, use it to protect much more the chemist. You have in the lab many chemical handling which are performed on the open bench. Why? Because you have not enough ducted fume hood in the lab, and they are far away along the wall. So many relatively small handling are performed on the open bench without protection, or with little protection. This kind of suction arms or canopy don't protect you at all. You have the feeling you are protected, but you are not. You need an enclosure, you need phase velocity, you need containment to be protected. So many applications performed on the bench can be easily performed in a ductless hood. In a small one, if the application is small and don't use large equipment, or larger one if the equipment is large, So, but you are not limited in the number of fume hood you are using in the lab, because it doesn't consume air. So you can put as many and protect many more people for many kind of application.
True. Very good. So we can still accept one more question if there is. So Ms. Laloux, can you stop sharing? I want to share these screens to the audience.
Wait a minute, I check where
Yeah. All right. So do scan the QR code here to fill up the feedback form. There's a few things we ask from you, especially if you want to have a recorded version of this presentation to share it with your colleagues, or the slides of this presentation. Some of the information of this presentation, we can actually give it to you, but you have to fill out the form and also tell us whether you want a certificate of participants or not, and also tell us what topics of interest you are interested. You hope we can we can deliver next round of public hour online safety talks, right? So all right, so do scan this QR code and then fill up our e-form. We hope to get your feedbacks and your suggestions. You will help us to do better next round. All right. So any more questions before we round out these sections today talks? Okay. All right. Seems that we have answered all the questions. All right. Very good. So we'd like to take this opportunity to really thanks Mr. Laloux. Mr. Laloux actually put a lot of effort to prepare this presentation. Actually, I learned something, even though I heard a few times, but this round, I myself also learned a lot of things from your presentations. So, and
it's my great pleasure to provide more information to you, Joseph.
all right. I think Erlab is a company that continues to grow.
In this field, we learn every day. We learn a lot of things. Every day we learn. And that's a good thing with this product. It looks like a relatively simple product, an enclosure, a filter, a blower. In fact, its impact is huge. And that's make me also passionate for this technology.
All right.
And I will be happy to share more information, more detailed information. If you are interested in knowing more about Ducted Fumehood, I was a member of the, I'm still a member, by the way, of the European Standardization Committee for Fumehood, member of the American Standardization Committee. I'm based in China, so I'm more versed into Chinese system. I'm a member of the Chinese Standardization Organization for Fumehood, which are going, by the way, to be officially introduced in a white book, authorizing designer to specify ductless fumehood for laboratory building. China is developing a lot of labs and lab building, and they want those labs to be energy saving and protecting the environment. So ductless fumehood will be officially in the white book published by the government.
It's good, interesting.
As you said, for the trend, this part of the trend.
Yeah, I think it's very important because ducted fumehood is the most energy consuming equipment in the lab. So if you change to ductless fumehoods, basically you can reach a zero net.
Change everything. You change everything. You really manage to have labs which are totally flexible, can be zero net energy building, which is also a trend in China. Without ductless fluid, you cannot achieve a lab to be zero net energy. Impossible. So only ductless fluid can do. You have a lot of type of fume hood. You have VAV fume hood, those kind of things. They cannot achieve. And are more complicated than the normal ducted fume hood. So only ductless can achieve.
Okay, all right. Thank you very much, Mr. Laloux. Thanks, our participants. Thanks to our end user, because you are the most, you are very important because you use the fume hood every day. We hope that you learn something from these presentations. I would like to also thank our reseller and also our partners, our the furniture fabricators. So I look forward to work closely with you. I think when we sell ductless fume hood, we are not selling a lab furniture because we are selling a safety equipment. We want to protect our user. All right. So we can do it together, and Erlab is behind us to support you so that you can offer, a proper international standards compliant, safety equipment to the end user. So everyone wins, and we can work like what our slogan say: team together, better solutions. All right, thanks for your time. And we hope to see you again in our next public talk. Do fill up the feedback form and also visit our website, our Facebook and LinkedIn. So thank you very much for your participations. So we honor our time. Now it's 4:15. So we will end our talk here. Thank you very much.